Hi, in this video I'm going to show you using using the TRS-80 Model 1 and 2. I guess I had a color computer too. But I'm using the 1 emulator. There's not much difference between the two, I guess. But we'll pretend I'm using a color computer too. And anyways, so what I'm doing here is I've decided to make a Venn diagram, and I'm sure most people probably know what that is, but some people might not. It is it's for statistics, and anyways, it's the Venn diagram is a way to display statistics, and so the program's not done yet, but I want to show you what I have so far. Okay, so say we have a this type of statistic. It's almost like when you're done with the Venn diagram, you have a visual data representation, like a line graph, a bar graph, pie chart. This is just another way to show data in a chart fashion. But anyways, let's say we have 20 people, and we have they have a choice. Say it's pets. Say so 5 of them will say. Now the way I have this arranged in the computer, you have to make one category bigger, and I don't remember if it was A or B. So let me check my math real quick so I don't mess this up here. Let's see. Don't know here. This is strange. Let's see. You know, guys, I don't even know. I write these programs and then I forget even how I did it. So let's just say 12 of them have cats and 8 of them have dogs. And, other is some people might not have cats or dogs. But we're going to keep this simple for right now. So it just stays the same. We have a population of 20 people. 12 of them have cats, 8 of them have dogs, 0 have both. So there's quite a few categories. You have a population, then you have category A and B, and then you have individuals that have both, and then you have some that don't have either none or other, but I'm not that far yet. But what I want to show you is that once I hit the space bar, if you look up here, it shows the population, which is 20. And forgive me if these numbers aren't perfect, but I did this in a hurry because I really wanted to show this to you. I've developed a way to display numbers on the graphic screen in PMODE 1, and I want to show you that whatever population I type in, okay, that number appears up here in the corner. Now you see 91. I can display 1 through 9 in 0 in any order, very relatively simply. And this is the fun part of it. So we get the 33 up here, and some of these numbers are a little blotchy, but I wanted to make them as quickly as possible and as simply as possible. But I can display any number, and the computer does the work, and I don't have to do anything. There's the 35. I'll do a few more. 77. I could pick any number in the world here, as long as it's a 2-digit number. And yeah, those are supposed to be 7s. Okay. I can do 11. As long as it's a 2-digit number, there it is. Okay. Any number, trust me. We'll do, we'll try 64. And there it is, 64. Okay. Now, it's not that hard. Like, the thing is, you have to engineer your code, and you have to use your computer brain in order to do this. And I'm going to show you how this is done, because this is frustrating. It's not that you can't display numbers on the graphics screen. It's that you want a particular number to be displayed. Now, how do you do that? Anybody could draw up a font, which is what I'm going to show you right now. So the strings here are the font. So I simply have number $, and I have 1 through 9, and then 0, and that is it. So all we need to do is come up with this font. And so it's number $, subscripted by whatever the number is, and you then the tricky part is, once you do that, you have to figure out a way to get them to display the number you're trying to display. And this is the simplest way I could figure out. All it is right here, 2 lines. And this is how it's done. Now, when I enter the population, it's going to come up as P, input P, okay? So then what you do is you say, you want the number in the tens place first, from left to right. So you say tens equals integer P divided by 10. And so what that's going to do is, say our number is 12, it's going to divide 12 by 10, and if you have to use the integer command, because 12 divided by 10 is 1.2. Integer only looks at the whole number, so we're going to get the 1 in the tens place, okay? And we know, and the computer knows tens equals that figure. It's a single digit. Then we move on to the ones place. So I couldn't spell out ones because it's conflicted with on. So I just used O. So what does O equal? O equals population, say it was 20, minus the tens. So in this case, if the number was 12, it would be 12 minus 1. Okay, but that doesn't do it. So we have to regurgitate the actual number here. And if you do 12 minus 10, you take the 10 out of it, you're going to be left with 2. So now O equals 2, and we have our figures side by side, okay? Try to follow me here. So we have 12 minus 1 times 10, so that O equals 2, 10 equals 1. Then we have to put it to graphics. And what you do there is you just display them side by side, starting with the 10s and then the 1s. And there's a little bit of bumping around in here. You have to make enough space in between so they don't overlap. And that's it. But the key to this is placement on the screen. So we use BM $, and we have to go sub each time before we draw it to change the value of BM $. So for example, when we're doing the 10s, we go sub to 30, we define BM $, which is the BM part of the drawstring, and we have X and Y in there that we can change, and then we do the same thing. Then here we bump it over so they don't overlap. We go sub back, and the X becomes 8, and we bump it over, and we draw the 1, the 2. So the 1, the 2, that's it. That's all there is to it. If you want any further clarification, or if you understand this, that's fine. If you want to make comments, go ahead. But my next step is going to be to draw the Venn diagram circles, because that's what a Venn diagram is. It's 2 overlapping circles. So to run this through one more time, I forgot what I picked here. Okay, we're going to get the output first, so you can read it. And then once you hit the space bar, we're going to get a graphical interpretation. There's going to be 2 giant circles here overlapping in the middle. So we're going to have category A, category B, category C is going to be both. The population will be displayed over here, and neither or other will be displayed here, and then you can interpret your statistics. And so that's what that is. It's data interpretation, and you have to use a Venn diagram. You can't use a line graph or a bar graph or a pie chart or anything else to display this kind of data. So that's it, guys. Happy Sunday. And I did watch the show after. I joined it, but I had to leave, and then I didn't realize it was still going on. You guys have really long shows, and so I catch it on the backside after it's over. Thanks, Curtis, for going over my stuff. I hope you continue to watch and, have my stuff on the show. And I'll try to join next weekend for a little while in the discourse, hopefully. So, I thought that this was going to be a lot harder, but at first, you have this huge thing in your mind. How do I do this? And it's as simple as 2 lines. It's really as simple as these 2 lines, and that's it. And making a font. An inexperienced programmer, like what I did in my card games and things like that, you'll have tons and tons and tons of code if you don't know how to mathematically work it. And luckily I have a strong math background, and it just came to me like I'm in teacher training right now, and I went through structure of math 1 and 2, so I have a pretty good working knowledge of base 10. And so if you think of base 10, this right here is it, so it's really just a base 10 operation. performed on a computer, you know. So I guess that's it for right now. And so I'm just going to cut off of here and get this video out to you guys. I know you guys like watching this stuff, and I like making it, and I like interacting with you. So hopefully I get some comments on this one. All right, take care. Bye. Thanks for watching.